In 1960, there were 3 billion people on the planet. That had doubled by 2000 and will double again perhaps by 2050. FAO estimates and other international body estimates have emphasized the fact that both land-based agriculture and aquaculture resources are stressed, as are wild-caught fisheries. And without improvements in productivity and efficiency, it's hard to imagine how we'll meet the protein needs of the developing population over the next 20 to 30 years. That's particularly true when you think of developing markets where you now have emerging middle classes with a higher requirement for a better high-protein diet and in many instances, the healthy kind of diet that we Americans are used to.
I think about the benefit that this offers to the industry or to the fish farmer. There is no doubt in my mind that this type of technologies need to make it to the industry. You can use this technology to develop fish that are resistant to disease. Disease costs aquaculture billions of dollars annually. You can use this technology to make fish that have a better environmental tolerance. And if we do it right, they can produce the right health benefits. And we can also develop, and there is work in this field, fish that are like transgenic fish, are like bioreactors. They produce, they overexpress vaccines, and then you eat the fish and you get vaccinated. So I think, my opinion, it's my opinion based on my experience, that this technology is going to make it to the aquaculture industry, but, and there is a big but here, it has to have all the right safety measures. We have to calibrate the transgene to the physiological range, very important. We don't want to overexpress a hormone in like pharmacological level. And it's all about land-based technology, fully contained, recirculated land-based marine aquaculture, and it's you can start with city water, you make your own seawater, or if you have a pristine source of seawater in a well or something, you use it. And it's all about microbial communities, and this is where the biotechnology is, that remediate the water, they remove the waste produced by the fish, and the water cycles again and again and again. And obviously those systems that can be, that are land-based, generate no pollution, they are disease-free, they are very clean and produce a very clean product, as green as you can get a fish. They're very flexible because you can tailor the temperature, you can tailor the water chemistry, you can tailor the duration of the day, and so on and so forth. And as such, they are generic. In my mind, the key word to success in aquaculture is diversification, and you can diversify in these fish. And in the context of today's hearing, they are biosecure. They are completely biosecure, they are fully contained, and in my mind, those are the only systems that should be allowed or approved to grow genetically engineered, and by the way, non-native species as well.
FDA has not yet made a decision on the approvability of this application. We have not yet made a decision. We are here to hear advice and recommendations from the Veterinary Medicine Advisory Council. We are looking forward to their discussion. As I told you yesterday, we are not asking for a vote. We are specifically not asking for a vote. We're specifically asking for good, constructive conversation. We want to learn from you what you think about the way that we've reviewed this, and if you have any additional ideas for us.